This video is going to be about pedigree analysis. So pedigree analysis can be a really useful tool when we know what individuals in a family are affected by a trait or a genetic disorder, but we're not sure how that trait or disorder is actually passed on from one generation to the next. So before we get into actually figuring out the inheritance pattern of this disorder, there's a couple things about a pedigree that we should take note of. So when we have a pedigree, it's important to remember that the boxes are going to be males and the circles are going to be females. And so a line in between a male and a female is going to be a marriage. So something else to know is that shaded individuals are going to be individuals that have the trait or the disorder that you're interested in. So for this first generation, we have an unaffected male that married an affected female that had 4 children, 2 of which are affected, a boy and a girl, and 2 of which are unaffected, again, a boy and a girl. So now getting on to actually how this disorder is passed on. So if we start with this first marriage and look at the children that they have, there's not a lot of great information that we can really use to figure out how this is inherited. Because if this disorder was dominant, then if this individual was homozygous dominant, then all of the children would have to be affected. So we at least know that this individual is not homozygous dominant, but we could still have this individual be heterozygous, and then this individual be homozygous recessive and get this distribution of this trait. And the same could go if it was a recessive allele and this person was heterozygous and this person was homozygous recessive for this disease. So we kind of need to look away from this first group of people. So next we'll look over here. So this grouping is actually really helpful in figuring out how this disorder is inherited, because we have an affected child with 2 unaffected parents. So we know right away what kind of disorder this is. So we know that this has to be a recessive disorder. And so this individual and every other affected individual is going to have a homozygous recessive genotype. And so the way we know this is that if this were a dominant disorder, then every affected individual would have an affected parent. And that's not the case here. So we can rule that out right away and just know that this is a recessive disorder. So something that's unique about recessive disorders is you can have a recessive disorder that neither one of your parents has. And so the way that that works is that your parents would have to be carriers, which means that they're heterozygous for that gene. And so what a carrier means is these individuals have a dominant allele, so they display a normal phenotype, but they're heterozygous, so they also have a recessive allele that's just kind of hanging out in the background and not really causing any phenotypic effects. But when these 2 individuals have a child, one allele will come from each parent, and by chance this child got both of the recessive alleles from both of her parents and ended up with this disorder. And so now that we figured out how this disorder is passed on, we can look and try to figure out the genotypes of the individuals in this family. So we already know that all the affected individuals are homozygous recessive. And so we also know that the parents of this child, this affected child, are carriers. So looking at this first group of people, we have one homozygous recessive parent, and then we have one parent whose genotype we're not sure of yet. So we know that this individual, though, cannot be homozygous dominant, because if they were homozygous dominant, then every child would receive a dominant allele from the father, and none of the children would have this disorder. So that means that this parent has to be a carrier as well. And so since parent is a carrier, any child that he has with this woman is also going to be a carrier, because if they're unaffected, that means they got a dominant allele from their father, and then only recessive alleles could be offered by the mother, and so they got one of each. So moving on to this section of the pedigree. So this section of the pedigree is a little trickier. So this individual right here married an affected male, but we can't be 100% certain what her genotype is. She could have the homozygous dominant phenotype, or she could have a heterozygous phenotype and be a carrier. Genotype and be a carrier. So regardless, though, we know that both of their children are going to be carriers of this disease. And that's because, again, the mother would only be able to give these children a dominant allele. So then the father would have to give the only alleles that he has, which would be recessive. And so these individuals will also be carriers. As far as these last two, again, similarly to up here, we're not able to determine what their genotype would be strictly from the pedigree. So they could be homozygous dominant or they could be carriers. So just to review one last time, pedigrees are really helpful in figuring out how specific traits or diseases are inherited, and we can even use them to figure out the genotypes of a lot of the individuals in a family. And then the other individuals that we're not able to figure out their genotype precisely, we know at least we've narrowed it down to two options. They're either homozygous for something or they're heterozygous. But regardless, this is really helpful to have a really solid understanding of, especially when you get further into biology and onto genetics. I hope you found this video really helpful. The concepts and information presented in these videos will be true regardless of what biology course you're taking. However, the material we covered in this video is specifically referencing material covered in Campbell Biology's 11th edition. Remember that if you are an enrolled Baylor student, we do offer free tutoring on the first floor of the Sid Richardson building, and you can schedule a free 30-minute appointment to have one-on-one tutoring online, or you can stop by during any of our business hours. For more information about the services we provide, you can go to our website at www.baylor.edu/tutoring. Thank you.